Let's compute the C-index with an example. First, we'll get the permissible pairs. Remember that these are pairs with different outcomes. So we look at pairs that will have different outcomes, first considering AB, seeing that they have a different outcome. So that's one permissible pair. And we look at AC, see that these outcomes are different. We look at AD, see that those are different. We look at BC, we look at BD. And notice now for CD, they have the same outcome, so this is not permissible. Of these, now we can check for pairs that are concordant, where we're checking whether the higher estimate pair has the higher outcome level. So let's look at AB first. So in AB, the higher estimate is for A, and the higher outcome is for A. So that's concordant. For AC, we see that the higher estimate is for A, and the higher outcome for A. For AD, we see that the higher estimate is for D, and the higher outcome is for A now. So this is not a concordant pair. Let's continue to BC. So for BC, we have the higher estimate here, and the higher outcome here as well. So BC is going to be a concordant pair. We look at BD. For BD, the higher estimate is for D, and the higher outcome is for D. So this is also a concordant pair. We've covered all possible permissible pairs, so we don't have any risk ties. So we can now compute the C-index as the number of concordant pairs, 4, plus 0.5 times the number of risk ties, which is 0. Divide that by the number of permissible pairs, which is 5, to get 4 over 5. Now that we've gone through an example of how to compute the C for benefit by hand, let's see how we would process data to perform this computation. So we can split our RCT data into two groups, one that contains patients that got treatment and the other that contains patients that didn't. For each of the patients in both groups, we can now also use methods like the T-learner or the S-learner to estimate the treatment effect for each of the patients. We can then sort both groups by their treatment effect estimate such that the patients we expect will have most benefit will be at the top. Then we can match patients by rank such that the first patient in the treatment group gets matched with the first patient in the control group, the second patient with the second, and so on and so forth until we run out of patients to match. Together, the first match forms the pair 34-3. In the second column, we take the difference between the Y1 coming from the left and Y0 coming from the right to get the Y difference or YD. In the third column, we get the average of the treatment effect for a patient in the treatment and the matched patient in the control. So negative 0.34 and negative 0.33 have an average of negative 0.335. Now that we have the data in this form, we can compute the C-index with the second column, YD, as our outcome, and the third column, TE, as our estimate, and plug that into the C-index function like you computed in course 2. After this computation, we might get a C for benefit of 0.6 for the S-learner and 0.56 for the T-learner, allowing us to compare the performance of these two methods. So what does a C for benefit of 0.60 mean? The C for benefit means that given two randomly chosen pairs, A and B with different outcomes, what is the probability that the pair with the greater treatment effect estimate also has the greater YDiff? And with 0.60, it means that the probability that the model correctly identifies the patient pair with the greater treatment benefit is 60%. Congratulations on completing the first week of Course 3. This week, you have learned about how you can use machine learning to estimate the benefit of a treatment for an individual. You have learned about the challenge of working with data where we only observe what happens to a patient when they receive a treatment and not what happens if they don't get treatment, and vice versa. You have also learned about how you could still evaluate the quality of the treatment effect estimate, even in the presence of this challenge. You'll get to apply all of these learnings in your next assignment. I'll see you next week, which covers tools for extracting information from text.